Right, I want us to look at our second example here. It was taken from the exemplar paper 2014. We're given this diagram and these dimensions. AB is to BE. We're given the ratio there. AB is to BE. So negative ratio is 1:3. So kumbula ratio le, you indicate ratio differently. If this is x, this will be 3x. So this is 1x and this is 3x. Right, that is the ratio. So this is 1:3. Right, we're also given that AC, in this particular case, it is 3 units. So this AC is 3 units. So I don't circle it because it's the actual dimension, 3 units. And EF, where is my F? Oh, my F is supposed to be here. My EF is 6 units. EF from here to here, it is 6 units. So it's just 6 units. Might be centimeters, might be millimeters. And FD is 3 units. FD, we're told that it is 3 units. Remember, this is not a ratio. This one is a ratio. I've indicated it by circling it. And CG, this distance from there to here, CG, it is X unit. We're not given. It is X. We're giving it as X. Right. The first question, calculate the length of CD. CD. Where is CD? We're looking for that length, CD. Okay? CD, that's what we're looking for. You don't think of the problem, think of the theorems. Whenever I see parallel lines, I think of the theorem that say, whenever I've got a line drawn parallel to one side of the triangle, it will divide the other 2 sides proportionally. Right. A line drawn parallel to one side of a triangle, it will divide the other 2 sides proportionally. What do we say then? Let's do this thing. We know that since these 2 lines are parallel, we can simply say that AC over CD is equals to AB over BE. But because in CD, I always ngathanda uqala ngayo uCD. Kusho ukuthi ngasho ukuthi leli side over the other side is equal to this side over that side. But it's a material. Let's do it. Sithi la AC over CD, the one we're looking for, is the same as AC over CD is the same as AB over BE. Is the same as AB over BE. Right. Sifuna bantina, sifuna CD. But we are given the ratio of AB over BE. We know what is AB over BE in terms of ratio. So in other words, AC over CD is the same as, what is AB? AB is 1 and BC is 3. It is 1 over 3. That is the ratio. Kumbula sifuna bantina, sifuna bani uCD. uCD. Okusho ukuthi uCD izoba uba. We cross multiply. CD times 1, it is CD, it is equals to 3 times AC, it will be equals to 3AC. 3 times AC. That is the value of CD. Do I know what is AC? Do I know how many units is AC? We do know. AC is just 3 units. Therefore, where there's AC, we push in 3 units to find the value of CD. So our CD will then be equals to 3 into 3 units. AC is 3 units. So CD will then be equals to, what is 3 times 3? It is 9 units. So we know now that CD is 9 units. Remember the ratio, it's any ratio. It's 1:2. It should be the same ratio, 1:2. In other words, this is 3 over 9. What is 3 over 9? It is 1/2. So the ratios are the same. Right. Let's move on to the next one. We're looking for the value of x in that next problem. X. Where is x? This is where x is. C. We use these parallel lines. Now it says x, this distance x. Is it possible for me? Okay, let me see. Let me see what to use there. When you use that ratio, this over that is equal to this over that. Okay, if I use these parallel lines, I will say this over that is equal to this over that. Yes, I do have it. So I can use these parallel lines. A line drawn parallel to one side of a triangle, it will divide the other two sides proportionally. That will be saying this over that is the same as this over that. Right, let's write that down. We are saying, komuthi sifuna bantilala, sifuna value x. So we can simply say that this, which is dg over ga, let's write that down. This over that is equals to this over this. Let's write that down. So man, with gd, this, which is gd, do I know that value? Let me write it down. It doesn't matter. gd, let me say dg so that I'll see where I'm coming from. dg over this over that, over ga, over ga is equals to, let's do it again. We're saying dg over ga, these are parallel lines, will be equal to df over fe. Yes, it will be equal to df over fe. Right. Sifuna bantinala. Sifuna value x. How can we bring x out of what we've written there? We don't have a problem with df over fe. df over fe. It will be 3 over 6. That's not a problem. So we don't have a problem with this side. df is 3 units over fe. fe is 6 units. It is 6 units. Right. Let's deal with the other one. Remember that it's going to go back on x. It's going to go back on x. And there's something that I know. I know this distance from there to here. I know this distance. We'll go to 9 units. 9. This distance is 9 units. Okay. Bugandana. Sifuna tina dg. Uba no dg. If we see as yonke that distance, let distance, ile distance yonke ususa le. Kwakha le distance. Yonke le distance le. Uma ngase ngisuse le distance le. Susele. Kuzoba yile dg engofuna. In other words, dg is the same as 9 minus x. So instead of dg, I can write 9 minus x over. Let's do that again. Instead of dg, uyo yonke le distance u9 ususele uzosala le dg. Right, over ga. Let's look at ga. Ga in terms of x uba. Ga. Ukusuka la uzala u3. Ukusuka la uzala bani? U-x units. So ukusuka lapha kuzala uba ku-x plus 3. So instead of writing ga, I can write x plus 3. In that way, ngifuna ukufaka lo x engimdingayo. So to write ga, to write my ga, it is x plus 3. It is x plus 3. It is equals to that ratio, which is 3 over 6. What is 3 over 6? It is the same as 1 over 2. With 3 la uyangaki, uyaga 1. With 3 la uyangaki, uyaga 2. So it is 1 over 2. Right. We're looking for x. Let's try and clean our equation now. Let's cross multiply. So what will I have here? This times that and this times that. Let's call it cross multiplying. So x plus 3 times 1, it will be x plus 3. Then cross multiply this one. This will be 2 times 9, it will be 18. 2 times minus x, it's going to be minus 2x. That's what we have. Let's put all that we need on the other side. Just funny value x. So far, I no x is equal to something. So kong no x are going under 1. When we do that, this negative x should come this side. Maizangala is positive 2x plus no x as negative x about 3x is equals to. We already have 18 this side. So we've got to take 3 that side. About negative. 18 minus 3 equals 15. Is it 15? Yes. 18 minus 3 is 15. That is funu x. In other words, loko ngala kuyalingana lokho ngala. With 3 times banike ozokwenza 15. With 3 times 5 owenza 15. Okusho x umele bani umele 5. Kusho 2x umele endaweni kabani ka 5. So that is the value of x. X in this case is equals to 5. The next question there, we're looking for the length of BC. BC. Let's look at where BC is. This is BC. This is BC. Right, we're looking for the length of BC. This is BC. BC. We don't know what BC is. All right, let's push in what we know now. We know that this is 9. If this is 9, and x is what? And x is 5. So what is this distance? It is 4 units. So GD is 4 units. Sesiyamazi manje. Iubani le? Iu-5. Right. So it's 4 plus 5, it's 9, plus 3, it's 12. So that whole dimension, 80, is 12 units. Right, let's look for the length of BC then. Nangu BC esimfunayo. But siyazi, masebenzisa ama-similar triangles. Ukuthi, if two triangles are similar, then the ratio of their sides are also the same. Now, look here. We know that since these two are what? These are parallel lines. If the two lines are parallel, the corresponding angles will be equal. Meaning that this angle here will be the same as this angle. Ah, that's very good. Take note of that. This angle is equal to this angle. Why are they the same? They are corresponding angles. This angle here is equal to this angle here. They are corresponding angles. What I've done there, I'm taking these two triangles. Let us look at them in this way. If I've got this triangle, the bigger one, we've got A there on top, we've got B, we've got E this side, we've got D this side, the bigger one, as well as the smaller one. This smaller one. We've got A, B, C. We've got A, we've got B, we've got C. These are the two triangles that I'm comparing here, and they're similar. Why are they similar? We've just seen that with a triangle enkulu, u-A ukhona, kule encane futhi u-A ukhona. It's the same thing, kuyalingana. So this A is equal to that A. Let's check whether angle E will be the same as angle B, because they are in the corresponding positions. Where is angle E? This is angle E. Ah, it is the same as angle B. They are corresponding angles. So this angle here is the same as this angle. Then the last one, for us to conclude that those two triangles are similar, we need to prove that the angles are the same. Corresponding angles are the same, D and C. C and D are the same. Then we can show that this one is also the same as this one. So these two triangles are similar. Now, if two triangles are similar, then this side over that side will be equal to this side over that side, equal to this side over this side. Now, with that, we've shown that triangles are similar. We can apply the theorem. BC. This is the length that we are looking for. Hence, BC in whatever I do. Let's look at what we have. Do I have BC? No, I'm looking for it. Do I have AE? AE, let me not go that route. Do I have AD? AD, nangu AD. Akhona ama dimensions akhona. This is 4. X squared to be about X plus 5, which is 9, plus 3, which is 12. I do have AD. Let me push it in there. I do have AD as how many units? As let me confirm, it's 9 plus 3, it's 12 units. AD is 12 units. Let me check if I have AC. If I can get AC, I'm winning. Check AC. Do we have AC? The dimensional AC? Do we have dimensional AC? Yes, we do have AC. It's how many units AC? It is 3 units. You go and push it where it belongs. AC is 3 units. Ginayole. Gifuna bani UBC. I'm looking for this. Let me check if I do have ED or DE. Come into our diagram. Do we have DE? DE. Do we have this dimension? Yes, we do. This is 6 plus 3, which is 9. So we do have DE as 9. Ah. Then we can work this one. Snako. Then we can find BC. It's in the if two triangles are similar, then the ratio of their sides are the same. Iyalingana ratio of my side. Let's start with this ratio. This will be BC over 9. I'm starting with the smaller one because I'm looking for BC. So BC over this side, which is 9, is the same as, let's look at this, adding up. So it's this side over this side. So it's going to be 3 over 12. Ah, this is what we have. Let's make BC the subject of the formula here. It's for BC. So if I want to have BC on its own, I've got to take this 9 away. So BC will be equals to this 9, it will be 9 times 3 over 12. Right, what do we have here? Let's check it out. BC will then be equals to, with 3 goes once, with 3 3, 6, 9, 12 goes 4 times. So that is the answer. Let's tell it now. It's 9 over 4. This is the value of BC, 9 over 4 units. Because we're not given dimensions, whether it's centimeters or kilometers, but you always write that units. It's 9 over 4 units, or 2 and 1 over 4, 2 and 1/4 units. All right, let's look at the last example that we have here. We've got to find the value of the area of triangle ABC over area of triangle GFD. Let's look at those two. The area of triangle ABC. ABC, this small one, remember the previous example that we did over area of triangle GFD. GFD, this area over this area. Do we have 90 degrees in this area? No. If we don't have 90 degrees, what do we use? Triangle formulae. Which rule? The area rule. Okay, let's look at what we have. We do have this side. We've just calculated BC. Remember that? What is the value of BC? BC is 9 over 4 units. It's 9 over 4. This will guide me. I do have 9 over 4 this side. I do have that side. So this becomes my included angle. So this is my angle of focus. Okay, let's look at the next one. So that was the area of triangle ABC. Let me look at the other area of triangle GFD. GFD, this triangle. Let's look at what I have. The dimensions that I have. I do have this one. I do have this one. This then becomes the included angle. But there's something special about this included angle. It is the same as that one. Remember the other one, the corner C go be look for when but the second one C corner the angle lapha, corner angle lapha. But these two angles are what? Are the same because they are corresponding angles. Now when we use the area rule, because we want to find the area, so we'll use the area rule of triangle ABC. So the area will be equals to half the sides of the first one, ABC, half of this times this. So it's going to be half of 9 over 4 times 3 sine of angle C. Right. That is the area rule. Half of left side times left side sine of this angle. It's the same thing you want to look of GFD. GFD, it will be half of this side times this side sine of that angle. Let's write that down. So this will be divided by half of my side just now with 3, no bani, no 4, sine of D. So that's what we have. We want the value of that. This one can go with this one. This one can go with this one. We've got 9 over 4 divided by 4. But it is important that we should know that but angle C is the same as angle D. Why are those two angles the same? Why is angle C equals to angle D? They are corresponding angles. Grade 8, grade 9 becomes important here. They are corresponding angles. Corresponding angles. They are corresponding angles. In other words, whether it's C or D, C. Now, when you do that, you can see that this is the same as sine D, because they are the same. So what are we left with here? We are left with 9 over 4 divided by 4. This is 4 over 1, right? This is 4 over 1. Let's change the sign into times. We'll have 9 over 4 times 1 over 4. Right, what is the answer here? It is 9 times 1, it is 9 over 4 times 4, it is 16. This is the area. Remember, my area will be divided, so it's 9 over 16. Thank you.